Hey guys, I know that you are doing okay. That's why you keep on watching this video. So first of all, today I wanted to talk about the welds and the welder himself. Alright, so here I've done my best to break down stuff how they work. So first of all, let's say we have a project X, that's the name of the project. So from that project we need a welder, okay, to be part of the project. So what we do is we go to the welding engineer. Okay, so the welding engineer, according to the project, whether it's a bridge construction, whether it's a train construction, whatever it might be, then the welder give us what he wants. So he wants the welding engineer give us what he wants. So he wants a certain process to be used for that project. So it might be TIG, MMA, MAG, and so and so. And then you want a certain position according to how the welder will be welding, either horizontal position, vertical position, overhead position, or flat position. He says it's there. Then you want the welder to use a certain voltage for that project. Then here is how it comes. Then for the welder to be part of the project, a welder must go and weld this kind of stuff that you see there. Okay, so he's gonna go and weld these two plates with the specific position that the welding engineer said, yeah, with the specific process that the welding engineer specified here. All right, after that, after he finishes everything with the specification, with the voltage, everything is done, then this is how it comes. This is how it comes. Then for us to qualify the welder to be part of the project, what we do, we come and cut there. We cut maybe there according to the standards that they're going to use, the standard codes, whether it's ISO, whether it's ASME, whether it's AWS. Then from there, we come here. Here we're having fillets weld. These are fillets welds. This is kind of what you see there. So this is kind of what was the kind of. Alright, then we come here, we check how this looks like, how the weld is. Then we check, we realize that there is a failure there. I've zoomed in for you on the screen there. You can see it. So if I had to draw lines here, to draw straight lines here, and here as well, you can see I'm having a problem with lack side wall fusion. So there is a lack of side wall fusion between this welding and then this plate thing. So here I'm saying this welder cannot be part of the project unless he goes and welds other plate which says that he can weld using the same process, using the same position, using the same voltage and so as specified by the welding engineer. So yeah, I'm having this kind of problem, like the one that you see here. Please zoom that one in, the one that you see here. So I see that I have a lack of internal fusions. You can see those are the runs. Where are the runs? That's run there. So there's a problem of fusion between the two runs, between the wall, in the walls. So that's one. For that, I'm gonna say this welder is not capable of doing what you have to do in that specific project. So then you need to go back and reweld other plates so that it can be part of the project. So here I'm going to show you. So these here are fillet weld. This is single-sided welded. This is double-sided welded. This is single-sided welded. This is actually a full penetration. Okay, this one here has fillet weld. These are partial penetration, full penetration, partial penetration, and these ones here are that weld. Alright, so we're gonna talk about weld and stuff next time maybe, but I wanted you to focus on what you see there. So welders know, and then as we know, as engineers, as technicians, as what we are, what you might call ourselves, it's very important to know how things work. So that when you are exposed to it, you know what you have to say. You know how you can defend yourself. You know how it goes. You know how the business is run. So you have to know those things. So today we're going to talk about a WQR, a PQR, and a WPS. Actually, we're not going to be talking about a WQR because I believe last time we spoke about a WQR. So, what you need to know is a WPS
is a welding procedure specification. It's a blueprint which gives the guidance to the welder on how to weld, to do a specific welding with a specific material or alloy. Right. Then a WQR is a welder qualification record. It's a document that specifies, that indicates that the welder has the ability, okay, has the ability, he has the understanding to work within a specified WPS. And then a PQR is a report. PQR is a procedure qualification record. It's a report of tests, and which test demonstrates that the WPS that has been written is worthy, all right, is worthy to be used for under a specified standards code. Standards code, as I said here, it might be ISO, it might be AWS, it might be ASME, it might be the Canadian Welding Bureau, it might be the European Committee standards, right? So it might be that. So okay, then from there, after this has been done, so this WPS can be used, all right?
First of all, you need to know that a WPS is a document that allows repeatability of a specification. So what I'm talking about repeatability of a specification is how they're going to apply the procedure. So here, for a WPS to be accredited, to have the accreditation, for WPS to have the accreditation, this needs to be supported by PQR. We're talking about tests that are done according to specific standards. Okay. So the standard might be ASME, right, which is American Society of Mechanical Engineers. It might be AWS, which is American Welding Society. It might be ISO, right, International Standards Organization, or it might be Canadian Bureau of Welding. Okay. So now, with this from there, we proceed with the test. So, as for instance, if we have to talk about, let's say, ISO 15614-1, which is a PQR, code for fillet weld, butt weld, as well. Here, if you can check that on my screen, so this is what it's telling you. So for ISO, what you need to do for a radiographic examination, you need to do 2 transverse tensile tests and 4 transverse bend tests, as well as 2 sets of impact, not forgetting the macrostructure as well as hardness. So that is the basics. So if you have to go in more details, you need to go on to check on the footnote A, B, C, D, whatever is written there. So for instance, when you have to do it according to ASME, what you do is you just go for full bends,
whether side bends or roots bends, as well as face bends. Okay, and it goes with 2 tensile tests. So for a WPS, we need to have a welder to be part of it, and then a welder which already been accredited by passing a WQR, which is a welder qualification record. So a WPS, actually, for a welder to be part of a WPS, you need to pass a WQR, which demonstrates that the welder has the understanding and the ability to work within a specified WPS. Right? So it's very important to know how these things work, because when you talk about WPS, PQR, WQR, we're talking about joints, we're talking about weld. Nowadays, the weld is the biggest part of joint that's being used in this world. So we need to know how that is being done, so that when you're exposed to it, you know how it works. So you know how it works. I'm gonna give a small resume here. So ask me 9 requires for a butt weld or groove weld. I'm talking about full penetration, complete penetration joint. So it requires two tensile, 4 bends, right? There might be side bends, 4 of them. There might be two face bends, and 2 bends. So now AWS, which is American Welding Society, requires 2 tensiles, 4 bends, which might be 4 side bends, 2 facing rods. But AWS gives a window to other addition that will be developed later in another video, of course. So ISO requires for a basics of 2 tensiles, 4 bends, which might be 4 side bends, 2 face, 2 rods, by a total of 4, 1 macro, right? 2 sets of impact, depending if there is provision of impact in the specified material that is being used here, and then plus hardness. Hardness also, it excludes group 1.1, right? As you can go in footnotes to know more about how it is, right? So yeah, so basically this is how it is, right? So this is how it is. So it was a great pleasure of mine to share this video with you. I hope that you guys gonna enjoy it, or we have already enjoyed it. And as I've already been saying, we're gonna be sharing a lot of stuff here, mathematics, science. So if you haven't subscribed, please subscribe, because you're gonna miss a lot. And for now, I'm gonna ask you to take care of yourselves, and see you for the next video. Cheers, bye.